Hey guys, Ben with Bigstuff3 here. How's it going? So in today's video, we're going to be going over the AFR section. The AFR section is very important to your tune-up because based on your air-fuel ratio targets, which is configured in this section, this is how your engine's actually going to run based off those targets. We also have closed loop settings. We have some custom tables we can make here in this O2 modifier selection table. But this is going to be the section we're going to be talking about in today's video. Now, one of the most important things to set up and configure, though, before we get into the actual AFR section, is to tell the ECU what your target air-fuel ratio is based on what you're running. Okay, so if you come over here to this hardware configuration section under your system button, you're going to have 4 different choices here. We're going to have fuel type of gasoline, ethanol, methanol, or flex fuel sensor E85. Okay, now why this is important is because if I was to choose gasoline, I'm going to input a stoic AFR of 14.7. Okay, if I want to do ethanol, though, E85 all the time, I'm going to want to input a different values. Okay, if I want to do methanol, I'm going to input a different value. So when you basically tell it what the fuel type is, you're going to give it its stoic AFR for the fuel that you're running. And this is very important because depending on the type of fuel type you're running, you're going to have a different stoic ratio. Now, as you can see here, when I highlighted this AFR ratio, this window opened up and it actually tells you what the stoic is of the different fuels. So if you want to run methanol, you're going to put in 6.45, ethanol E98, 9.01, E85, 9.77, and obviously for pure gas 14.69 and E10 14.08. You're going to want to input these different values because depending on the fuel that you're running, you're going to want to have a different stoic. Now, the methanol is 6.45, and you can run our Bosch 4.9 sensors and read methanol all day long and set your AFR targets in the 3s. It works fine. You do not have to get the Ntk option. If you're an all-out high horsepower dragless application, you're definitely going to want that. But with methanol getting as popular as it is, we're having a lot more street-based combos actually run that fuel, and the AFR reads just fine with the Bosch 4.9 sensors. And you can input the methanol target at 6.45 with your map that you're using. And then let's say you were done using methanol in the engine, you could then have a tune-up saved and set it up for gasoline with a target of 14.7, and you now have 2 different tune-ups set aside. But it's very important to come over here and set up the fuel type that you have with the stoic AFR. And again, we're going to cover a little bit more of that here later on. So once you get those 2 guys configured, you're going to be able to go over in the AFR section and start configuring it. Okay, so first thing is this O2 modifier selection. This O2 modifier selection is where we can actually turn on some generic AFR curves, if you would. Now, in our software, we're going to have Lambda and AFR. They both mean the same thing, but the Lambda value is going to be the true Lambda reading. AFR is obviously going to be calculated based off of that stoic number that we have plugged in. Okay, so we have a generic 1D Lambda curve here, same thing as AFR. And we're going to show you how you can choose between AFR or Lambda in your tune-up. Okay, so I'm going to close this back out here, and we're going to come back to that section here. But the first thing we want to talk about is this O2 and Egt Parameter section. Now, this is very important because depending on how you have this stuff configured is when closed loop feedback is going to kick on or it's not going to kick on. So in the O2 feedback control here, if I went to open loop, obviously here, it's going to turn everything off below it. All right, so here, as you can see here, our threshold turned off based off of coolant, RPM, coolant temperature, engine RPM, and everything else. So that would be open loop. This would not be running any type of closed loop at all. You'd be simply running based off of whatever your calibration is configured for, okay? So if I go back into closed loop now, I'm going to have my on threshold for RPM, off threshold for RPM, same thing for coolant, on and off. Now, the RPM threshold for on means that anything above 500 RPM, I'm going to kick in and allow closed loop to run. Anything below 300, I'm going to turn off. Now, you have to have the coolant temperature as well above 120. So once I'm above 500 RPM and above 120 degrees, closed loop is then going to kick in and take off and go. Okay. my coolant temperature would have to get back down to 110 degrees before my coolant threshold turned off. Now, something that's very important to remember is when we are warming up your engine, okay, when we have this coolant number in here set for 120 degrees, in your spark table, what we've done is to help out with spark. Down here in this lower left-hand corner, okay, this is actually the spark number that it uses. So some motors need more timing when they're warming up to have the engine run better. Some don't. So a little trick that we threw in there was if you put whatever number you have in there is going to then use this as your base number. Once you get above this coolant on threshold, it then kicks out and goes back to whatever you're running on in the map, okay? So, for example, if this was 30 degrees here, okay, in this lower left-hand corner box here, and the negative 11 inches of vacuum at 600 RPM, even though I was over here idling and the engine was warming up, my base would actually be 30, and if I'd idle spark working, it'd be working off of a base number of 30. Once I get above my 120 degrees, this number is then going to go away. As far as being used over here, we're now going to be on our base spark map. Quick little hidden secret inside there for you. So if you plug that number in there, it will use that number for idle and for startup. So I've had some guys maybe make this first call in 300 RPM, and that way you're nowhere near it, so they can stick that number to whatever they want it to be, and they have to worry about it. Then when it comes out of closed loop, we're then going to be riding on the actual main spark map, if you would, here at whatever these targets are. Okay? So I'm going to close back out my Spark Advanced table. Okay, so now once we have the on threshold for both coolant and RPM satisfied, we're then going to come down here into the closed loop step limit section. Now, this is a section to where this is basically how fast the closed loop O2 correction works, okay? So this is basically a time delay of going rich or lean. The default numbers are 10 and negative 10. These usually don't have to be adjusted too much, but these percentages are pretty good overall for all different fuel combinations. You don't have to really worry about this. Now, the closed loop gain is basically how fast, if you would, the PID reacts to a change in closed loop, okay? So 15 is a slower number. We recommend running 15 if you have our 8 O2 sensors, if you're actually in closed loop on all 8 O2 sensors, which you can be in our system. Nobody out there does that right now, and if you want to be in full and complete control of each cylinder, you got to slow that closed loop gain down, because if you're on the standard gain, which is usually around 35%, that would be going way too fast, because that oxygen sensor with that one cylinder is going to be seeing overlap. It's going to be seeing a ton of oxygen that may not be burned. So you want to slow it down if you're seeing one cylinder, okay? If you're seeing a bank of cylinders, which is what our dual sensor setup is here, this 35 number is pretty good. Maybe you may want to slow it down around 20 or so. If you're finding that the closed loop correction may be hunting a little bit, this is going to be the number that you want to use. It can go from 1 to 50, but typically in the 10 to 15% range is where you're going to want to be if you're in our 8-cylinder O2 correction mode. If you're in our dual O2 sensors, okay, or let's say you've got a supercharged, naturally aspirated, or twin turbo, you've got one O2 on 4 on a bank of 4, you can slow it down to around 20 or so if you want, maybe 25. But if you're just using one O2 sensor in a twin turbo application, or just a single O2 for anything you're doing, a 35 is a good number to work from, okay? So when we go up here to our number of O2s, you can have none, dual, or IC rim. Now, none, we typically don't have. Most of our systems that everybody gets always run at least one oxygen sensor. So you're always going to default to a dual, and this is only going to read one side if you only have one O2 sensor. If it's reading two O2 sensors, we're going to be then closed loop on each bank, okay? So a lot of guys that are supercharged, naturally aspirated, if you're twin turbocharged, will take advantage of the dual O2 sensors. This can be applied in either the Bosch 4.9 sensors or the methanol Ntk sensors that we run for the extreme low methanol readings that they are going to want to pick up. Now, this IC rim is what I was talking about as far as running all 8 oxygen sensors. This is going to pick up the oxygen sensors on the big bands. that are going to be on each header tube. Now, what's really cool about this is, let's say you're actually running dual O2s down in the collectors, plus you're also running 8 O2s on each individual header tube. You will actually be reading a total of 10 oxygen sensors in the big stuff, because we're going to be pulling in data from all 8 oxygen sensors in real time. It'll all be available to you in your logs for you. And if you wanted to switch back and forth between dual O2 closed loop control and the 8 individual cylinder O2 control, you totally can. That's what this section is for right here. Okay, you're going to want to plug into your Chevy bank type, into your engine bank type, whether you've got a Chevy or a Ford. You're going to want to plug in Egt units, whether they're in Fahrenheit or Celsius. Again, here in the States, we're typically Fahrenheit. ETM misfire warning. Now, what this means is that if we have an Egt safety going on, okay, telling us if a cylinder is getting too hot, you can plug in the motor to start misfiring, okay? So this number does not have to be low at all. I would recommend maybe a 28 to a 27 at the most. This will start misfiring the motor. You want a very slight misfire so you don't drag the motor down to its knees, hurt anything, but you also want to be able to feel it, okay? So 31 is full power, 0 is no power at all. So you do not need to knock a lot of this out. So 29 to 27 is usually what I recommend, and that's about it. Now, for our Ntk O2 sensors here in this section, we do not have a way to calibrate the Bosch 4.9 sensors, but what I'm going to show you is in the data log section, there is a NERST value that we use to see if they're working or not. Okay, it's called NERST. Now, with our expensive Ntk option compared to the Bosch's, we do have a way to make sure these are working correctly, okay? So inside this little dialog box here, it's going to tell you what to do. And all you basically do is take the oxygen sensors out of your exhaust, and you're going to want to let them hang in free air. With the ignition on, you're going to come over to this section, and you're going to hit yes. And what's going to happen is the O2 sensors are going to fire off, okay? And what you want to do is you want to come down here. If you follow my mouse, I'm down here in this lower right hand corner, down here to this Ntk wideband O2 tab in the lower right hand corner, okay? When you come over to this, you're going to have in this upper right hand corner a left bank Ntk O2 percentage and right bank Ntk O2 percentage. And what's going to happen is these numbers are going to start turning on. And if you go back to our little section here, it's going to say, hey, you should be looking for something in the 20.8 to 21.1 range of oxygen. Okay, that's what these guys are calibrated from the factory, and that's what they should be reading about. And this just simply lets you know that the sensor is working properly based on what it's reading in free air. Now, again, the motor needs to be cold, have these hanging in the free air. We don't want any type of exhaust or fumes around these at all. All we're doing is doing a check here. Now, we do not calibrate anything to work with the ECU. All we're simply doing is verifying the calibration of those sensors itself. This is not a calibration to sync anything up between the ECU and the sensors. This is simply a check to make sure that the sensor is reading okay. Since these sensors are on the more expensive side, we wanted to put a safety in there, a check in there, to make sure that they were working correctly, and that's what this is. Again, we're not going to calibrate anything to the ECU. This is simply a calibration check to make sure that the Ntk O2 sensor is working correctly, okay? So once you're on and your sensor or sensors are reading what they're supposed to read around that 221 percentage number, you're then going to come over here, you're going to turn off no, you're going to hit no, and then the sensor is going to turn off. Now they're going to be really hot, so don't handle those fast, because they're going to be extremely hot. They're going to be on. Let them cool down, and then go ahead and put them back into your exhaust, and then you should be good to go. If you do have an issue to where they're not reading correctly, send us some email, give me a call. We can see what we can do as far as possibly getting those sensors looked at, but it's either they're working or they're not. There isn't necessarily any real repair we can do on those guys, okay? The next is going to be the ability to choose the O2 display, whether you want to see your tables in Lambda or AFR, okay? So if I come back over here to my hardware section under my system button, If I chose gasoline and I'm in the fuel type, I'm in the Stoic AFR 14.7, okay, I can choose to look at my AFRs either in Lambda or AFR, okay? So I'm just down here in this section here where the O2 display is chosen. Now, if I come over here to my AFR table and I pull up my target O2 table 1, you're going to see that everything's displayed in Lambda, all right? Now, if I come over here to my O2 display and I choose AFR, okay, everything now changes to AFR. So you can look at these tables however you want, okay? Remember, this is just simply a calculation based off what it's reading in Lambda. That's how it gets these targets, okay? So O2 display, AFR, or Lambda, that's how you check this stuff out, all right, to choose whichever one you want. So that's the O2 Egt Parameter section. Let's move on now to the O2 and Egt Configuration section. Now, what this is for is, this is if you are running any type of Egt input, or if you're running our big bands with our 8 O2 sensor option, okay? So as you can see here, everything on the right is grayed out. It's because we do not have our Egt safeties configured, nor do we have our closed loop Lambda offset configured. So the first thing you have to do is, if you want to use this stuff, is come over here to the fuel settings and go to the fuel modifier selection table, okay? And over here we're going to have Egt add fuel correction down here on the bottom. We're going to have the Egt add fuel correction, and we're going to have the wide open throttle cylinder Lambda offset correction. This is actually where you turn these suckers off and on. So if I bring this window over here and I enable this, now you're going to see all my values populate here. Same thing at the wide open throttle cylinder enabled. Now I've got my population over here. Now what you want to do is, once you turn those on, you're going to basically set up and configure your Egt sensors to either to add fuel or to turn off based on a certain temperature that the Egt sensor is reading. Now this works with our big bands if you're using the EGTs. This works with our PCS setup. So if you're using the PCS Egt sensors, you could do that with those. And this also works with the race pack Egt sensors as well. All three scenarios, if you're reading EGTs, will work here. Now what you're going to have to do though is configure it so that depending on what you have set up as number 1 on your rim, okay, is going to be configured for that cylinder. So what I like to do is I like to go over and just make sure that once everything is up and running, is go over to the exhaust gas temperature section, and you could be either on the Ford or the Chevy cylinders. It's down here in this lower section here where this tab is here. Let me close this out. So down here on the bottom, we've got these Chevy individual cylinder GTs and the Fords. Okay, it's all the same thing. It's just laid out differently. What I like to do is put a heat gun or a lighter or something on that cylinder, and that way you'll know that, okay, I'm on number 4, and number 4 is also set up and is reading here properly. So that way you know which cylinder is what. Okay? So if I was to come over here, I'm just going to do one to show you how this works here. But let's just say I'm on a gasoline car and I want to have a number of 1600. If I get over 1600 degrees, I'm going to add in 25% fuel. Okay? Or 1800 degrees, whatever you want it to be. Okay, now I'm adding 25% fuel into that hole. Okay, now let's just say I went to 1950, I'm going to be shutting that hole off. So whether you have 8 injectors or 16 injectors, if I hit that temperature, okay, going down track, that cylinder is just going to turn off. You will not be firing anymore. Something's obviously getting too hot. This is to save a complete nuclear meltdown of your motor based on this setting here. Okay? Now, the last section here is this target closed loop Lambda wide open throttle offset. Now, this is for our guys that are running our 8 O2 sensors here. This is where you're based on whatever cylinder you've got. All right, you can now plug in a target closed loop Lambda wide open throttle offset. So if going down track, I've got some cylinders that are doing more work than the others. Typically, you'll add fuel, maybe pull a little bit of spark in those cylinders because the airflow wants to go there anyways. Well, now you can actually plug in an offset to that cylinder. So if you wanted to make one cylinder, okay, a little leaner, you can put an offset in there of 5 hundredths. or if I wanted to put a offset of negative 0.050, okay, if I wanted to be a little fatter in that cylinder, I can now target each cylinder individually based on its actual lambda target. This is not AFR now. This is lambda for this. Okay, that's why I'm only going for the 500ths there. But you can now target those cylinders to run independently in closed loop based on these wide open throttle offsets. Okay, so that section though, remember all this stuff has to be turned on. If you go back here to the fuel settings section and the fuel modifier selection, this has to be turned on down here in the lower left hand corner. Okay, EGT add fuel correction and wide open throttle cylinder lambda offset correction. Okay, that's the only way that you'll get this stuff over here to pop up. If I turn these back off, okay, there you go. Now I'm all grayed out. Now they can't work anymore. All right. So moving on here, let me close this out. Target O2 table 1. Now I have it set up for AFR. This is a table that we're using based up to 30 pounds of boost, and right here is atmospheric pressure. So this is where you're going to set your AFR targets based on whatever you have plugged in for your stoic for the fuel type that you're running. Okay, so for gasoline, these are pretty safe numbers based on gasoline. Obviously running a pretty fat up top of 30 pounds of boost. At idle, we're targeting in the 14s, mid 14s. This is where you're going to target your air fuel ratio target. Now, how this works here is that based on your fuel number is derived, your overall fuel number is derived from a couple things, okay? Whatever this number is in here in your fuel map, okay, this number takes into account the air temperature, the water temperature, the engine RPM, the manifold pressure that it sees, and then it also takes into account this number. So even if you're not running in closed loop, it looks at the target based on what you're trying to inject in the engine at that time of manifold pressure and RPM, and that's all part of the overall gross pulse width number that you're actually going to work with. Okay, so if I'm looking at 11.9 to 12.5, to 12.0 at about 11, 12 pounds of boost, that target is plugged into my volumetric efficiency overall number, which is what I'm working with here in the actual fuel table itself. Okay, so everything works with everything as far as the volumetric efficiency number. Again, the coolant temperature, air temperature, the engine RPM, the manifold pressure, this air fuel ratio target. Even if it's not in closed loop, we are still using this. Some guys get mixed up whether it's working in open or closed loop. It's always working. So open loop, closed loop, it don't matter. This table is always being used. Okay, I've got a previous video going over how to set up and configure this table however you want it, so you can go back and check that video out. But this is all fully configurable from the manifold pressure on the left to the engine RPM on the bottom. You can configure this to your heart's content. Okay, so the next section that we have here is the positive O2 correction table. Pretty self-explanatory here. Again, this table can be configured any which way you want. This one is set up for 50% positive correction. Okay, this can be configured for 0, but this is going to be how much positive O2 correction that the actual table has. Again, this is a positive number. Do not put a negative number in here. This is the positive O2 correction table. If I come back up to my AFR section, go to my negative, same thing. Negative O2 correction table. Can completely configure these tables based on what you want for engine or engine RPM or pressure. This needs to be a negative number. Make sure you have a negative number inside here. Okay, so that does it for the AFR section as far as the base parameters go. So let's get into this O2 modifier selection. Okay, so now that we have the generic 1D lambda curve open here, okay, we're going to click on enabled. And the most common type of offset that we put in here for the AFRs for most applications, if a guy wants to do this, is the ability to lower the AFR target based off of coolant temperature. So the easiest way to do this is to actually throw an additive term in here on here, plus or minus to the actual lambda curve itself, okay, not multiplicative, but additive, okay, and you'll see that when we actually have this open, if I come over here to my generic 1D table, I've got my Lambda curve right here now exposed, okay? You can see here other stuff is grayed out. Well, that's because they're not shown. If I was to left click on this Lambda curve over here, number 2, and you know, there it is. It's going to be open for you. So if you see stuff that is grayed out in the software, again, that's because it's not chosen, okay? So I'm going to come over here to my generic 1D Lambda curve 1 under my generic button. And again, what's typically going to happen here is we're going to have an AFR offset. So when we're colder, we're going to lower the AFR offset down. Because if I look at my AFR offset or my target O2 table, I'm obviously at 13.97 AFR. All right. Now this is obviously when I'm warm. I'm going to want to be that warm. Now, when you're cold, you may not want to target that low of an AFR, or if you prefer Lambda. So if I was to come back over to the AFR section and turn this all to Lambda, okay, you're going to see now that I'm targeting about let's just say 0.9 to make it easy, okay? So if I got 0.9 inside those targets, and if I come over here to my desired Lambda shift curve, now if I'm at 35 degrees, I'm going to be at 0.650. That's going to be extremely rich, okay? Most cars are over here in the 50 to 58 degree range, somewhere around there. And that's still going to point you about 0.7. Now, as your motor warms up, though, we're going to start walking away, and the shift is going to start going up. So in this application here, by the time we got to 0, we would have no more AFR offset. Again, it's very typical for somebody to plug this in. Now, let's say I didn't want to make it as extreme. Let's say I wanted to make it a 1/10. Just make this negative 0.100, okay? Come over here to this 104 degrees, hit interpolate, and now I've got a much more gradual curve. So now instead of targeting at 35 degrees, 0.6 or so before, I'm only going to be able to go to 0.8. So again, even in this 53 to 58 degree range, I'm going to be a little less than, a little greater than around 0.8 or so. Now, if you're not exactly sure what that number is, then you can just simply come back over here and just hit your offset targets again and do the math and figure out where you have to be. Now, this is how you set up that table, okay, for actually running this. But you cannot forget that when you turn on these generic curves, okay, you got to turn them on in the generic port editor. So if I come over here, okay, so now that the generic port editor is open, we're on this generic 1D Lambda curve here, okay? And how we're going to set this up is that we're going to want to look at the temperature of the coolant is less than 105 degrees. So whenever we're less than 105 degrees, we are going to allow that table that we have built to work correctly, okay? So this would only apply to warm-up, obviously. Once we get over 105, we're then going to kick out. That table was pretty much 0 by 105 as well. Now, this can be 135, this can be 150. It really doesn't matter. It's very application specific. You can configure it however you want to do it. But setting up the generic port editor this way with the values that you configure is going to be how that table is off or on. Now, it's very important that you remember you got to turn it on with the generic port editor. If you do not come over here, turn on that table, it's not going to work. Now, there's a million different parameters in here that you can choose from. Not literally, of course, but there's a lot of parameters in there that you can choose to activate those tables from. Now, if let's say you're stuck, though, you're not exactly sure what point you actually want to use to turn this on. I use this stuff all the time, so obviously I know that temperature T coolant _ F _ filt is the coolant temperature. Let's say you weren't 100% sure on what to actually plug in here to the generic port editor. I've got another video explains all about this generic port editor section, but just as a quick refresh, let's just say, for example, on the main dashboard, I'm here and I want to know, here's the coolant temperature right here, okay, right here in the middle. If I don't know what that actually is in the generic port editor, if I right click on that guy and I come down here into designer mode, it's the bottom of this window, it's called designer mode. It's now going to populate a gridded setup, but this is basically in the background setting up all the dashes. If I come over to dashboard designer, I right clicked, okay, over the coolant. I left click on, or just hovered over dashboard designer, and I come down to this properties dialog. Okay, now you can edit anything you want inside here. This is just me showing you how to figure out what that point name is called. Okay, so go to the properties dialog and you're going to see, oh, it's called temperature coolant filter. That's what this channel is called. So you now know what to go into the generic port editor for any of these points. So if you wanted to work with vehicle speed over here, if I looked at this one and I right click this guy here, again, dashboard designer, properties dialog, vehicle speed. So that same vehicle speed channel will be in your generic port editor. Okay, same thing if I wanted to come over to the gross pulse width average. Not exactly sure what that's called in the generic port editor. Come over here to the properties dialog, injector underscore gross pith underscore average. Okay, so that's how you figure out what points to actually grab and use in the generic port editor. Just right click anywhere, open up designer mode, hover over a point, right click again, dashboard designer, properties dialog. Okay, go ahead and build anything you want, or configure your generic port editor, do anything you want that way. Now that I'm done, I'll just go anywhere else and get out of designer mode. Okay, so now my generic 1D table curve is built and you're all ready to go. Now, what's very important is if you're doing this offline, you're going to send over all these changes with the ignition. You're going to send everything over. There's going to be a demo report. You're going to say, yep, send over all my offline information. You got to cycle the ECU off, okay? In order for all these changes to make, anything you do with the generic port editor over here has to have a cycle of the ignitions, because whenever the ECU boots up, it populates all this good stuff, all right? So if you're online, same thing. If you're online with the ECU, you're doing this, you're going to burn it, and you're going to turn off the ignition, then you're going to turn it back on, okay? You have to do a reset of this of the ECU for anything in the generic port editor, okay? So that's the AFR section itself, and it's pretty self-explanatory once you start digging through this here. I'm Ben, Bigstuff3. Give us a call, text, email if you have any questions. Please like, share, subscribe to this video, and we'll be talking to you soon. Thank you very much, and have a good evening.